Good morning everyone and welcome to today's webinar, number 9 for 2021. My name is Kira Proctor and I'm the Managing Director of the A. Proctor Group Limited, and today we're going to be looking at high-rise and modular construction and how membranes can be used in facade and roofing applications on these kinds of projects. This webinar was originally broadcast almost exactly 1 year ago in May 2020, but today we'll have a brand new Q&A hosted by Carol Michalak with our team of experts. So as usual, any questions you have for our team, you can type them into the chat box here, DM us on Twitter @ProctorGroup or email webinar@proctorgroup.com. If you've missed any of our series of webinars, you can go back and review them right here on our YouTube channel or via our Learning Hub at www.proctorgroup.com. You can also book in for follow-ups with our team of specialists or order physical literature or sample packs. We're going to start off today by looking at some of the key principles of design for manufacturing and assembly. We'll then consider the ways in which we can use a variety of construction membranes to both align with these principles and comply with the building regulations. Following on from this, we'll consider how these strategies and materials can be applied to facade systems, both low and high-rise, and how they can be incorporated in upgrade works. Finally, we'll take a look at some projects where the principles have been put into effect on sites. Design for Manufacture and Assembly, or DfMA, is an approach traditionally used by other industries, such as manufacturing consumer products. This focused on the role of the designer in increasing both efficiency and quality of the manufacturing process. The basic principles are based on recommendations going back to the Egan report, Rethinking Construction, in the late 1990s, which focused on more tightly integrating project processes, adopting techniques and strategies from higher volume industries like automotive, to, in Egan's words, do it entirely differently. How feasible the entirety of the Egan report was, or remains, is something we could discuss for several lockdowns and still not resolve. But the spirit of the report can be clearly identified in the offsite sector, where factory-based manufacturing simplifies the adoption of this approach. The key principles can be identified as: minimize components, thereby simplifying supply chains and assembly processes both on and off-site. Ease of fabrication, focusing on using adhesive bonding rather than mechanical fixings where appropriate, and ensure the design facilitates the ease of both off-site manufacture and on-site assembly. Tolerance and clarity of parts, ensuring the design performance criteria are within the capabilities of the manufacturing and assembly processes, and minimise the scope for unclear processes to produce substandard results. Minimise the on-site use of flexible components such as gaskets and rubber seals, which can be more difficult to handle and correctly assemble, particularly under adverse conditions. Finally, reducing adjustments. By reducing or eliminating the requirements to make intentional fine adjustments, the necessity of unintentional adjustments can also be minimised. Taken together, these principles aim to ensure that the design performance of the building envelope matches what is built, not simply by demanding strict adherence to design specifications, but by writing those specs to ensure adherence is the simplest and therefore most likely outcome. The various approaches to construction derived from these principles are typically referred to as modern methods of construction, a broad term encompassing everything from timber frame housing to 3D printed concrete elements or cross-laminated timber structures. The common thread of all these types of building is, however, reducing the scope for variations in design performance arising from the construction process itself by shifting processes off-site into a more controlled environment. In this context, construction membranes have several important roles to play in ensuring these objectives can be met. But in order to maximise their effectiveness, there is a need to properly understand the range of design considerations applicable. Anyone who's been following our series of webinars recently will hopefully be pretty familiar with this diagram now, as understanding and controlling the heat, air and moisture movement within structures is the core principle of what we do here at the Proctor Group. In the context of our discussions today, we have a broad range of factors influencing this, as these methods of constructions can be and are applied to every type of structure. Timber frame has long been used in domestic housing, particularly up here in Scotland, but it's becoming increasingly common in other sectors and geographical areas. Likewise, volumetric building is increasing and expanding, and systems historically more typical of high-rise are finding use on low-rise projects. So, it's becoming more likely than ever that specifiers will have to learn to work with a huge variety of different detailing techniques and materials. Whatever the situation, the first thing we need to consider is the type of building fabric we are dealing with. Concrete, steel, and timber-based buildings all respond differently to moisture and contain different amounts of construction moisture which must be allowed to dry out. For example, buildings with a lot of in-situ concrete can take several years to fully dry out. This excess moisture load must be accounted for at the design stage. Construction moisture can also come from the weather, and this must also be taken into account along with the weather conditions the building will be subjected to once completed. Being weathertight earlier in the construction process and generally being composed of drier materials, off-site construction has an important advantage hygrothermally. By reducing the initial moisture loading on the building fabric, the design can be more precisely tailored to manage moisture associated with the occupants of the building and the uses the building will be put to, leading in turn to a more efficient fabric envelope and building system. The influences of these three aspects can then be assessed in terms of the heat, air, and moisture movement within the building. This takes into account the heating of the building as well as the air leakage effects and response of the building fabric to the absorption and desorption of moisture. Factors such as the position and performance of the fabric insulation can also be considered. Building regulations. As with any type of construction, the basis of good design in modular construction comes from a good understanding of the building regulations themselves. Today, we'll be focusing mainly on the documents relating to energy performance and condensation control. So that would be Approved Documents L and F in England and Wales, Technical Standards 3 and 6 in Scotland, Technical Booklets K and F in Northern Ireland, and Guidance Documents L and F in the Republic of Ireland. We'll also consider the implications of these systems on fire performance, which is covered in Part B for England and Wales, Section 2 in Scotland, Part E in Northern Ireland, and Technical Guidance Document B in the Republic of Ireland. While the specific details in these documents may vary a little, the principles behind the guidance and the recommended approaches are broadly similar. So, while we try and keep things as broadly applicable as possible, we'll flag up any significant differences where they arise. The primary design consideration we're looking at here is limiting unplanned air movement throughout the building fabric, whilst reducing the risks associated with condensation and excess moisture. The most important of these considerations is where in the building element we place both our vapour control layer and our air barrier layer. Traditionally, these two functions would be performed by the same membrane, as most vapour control layers will also perform the function of an air barrier. It's by no means a given that this method is suitable for all projects, however, and this is particularly true of façade systems. For some façade build-ups, the vapour control function may not even be necessary, and the inclusion of the vapour control layer simply adds an additional process and more complexity for no benefit, just one more thing to go wrong. Which leads to a third consideration. Is using a vapour barrier to control air leakage in fact a liability? While this certainly isn't the case on every project, if our overall design strategy is to simplify and reduce potential points of failure in the design, it's something worth bearing in mind. If we're proposing removing the vapour control layer, we need to be sure that the element is capable of controlling any risk of condensation. As regular viewers of our webinar, you will know by now there are a couple of different ways we can look at assessing these risks. Historically, a process known as the Glaser method was used to assess this. However, this method makes a few assumptions that limit its accuracy. In contrast, the newer WFI method allows us to account for the variable external influence of weather conditions, along with the effects of the fabric's capacity to store and release moisture. We can also look at how these factors interact over longer time periods. The steady-state analysis used in the Glaser method, while useful for quick and simple checks, does not always provide a sufficiently detailed picture of the long-term performance of the structure. This more detailed analysis can allow us to consider solutions that may not appear acceptable when assessed under the Glaser method. In our example construction here, the internal vapour control layer can be removed altogether without creating a condensation risk. If we remove the vapour control layer, we still need to manage our air leakage, and this can be done simply and effectively using an external air barrier membrane, like our Wrap-Tight. This simplified and more effective process allows designers to target more ambitious air leakage rates at the design stage, taking advantage of the improvements in energy performance this brings. Reducing the air leakage from 3 meters cubed per square metre per hour down to 1 can have significant positive impact on the energy performance of the building, meaning we can reduce the insulation thickness required or the specification of the insulation boards themselves. This can offer designers more flexibility in insulation types used, for example as regards fire performance or increasing internal space available to occupants. If implemented in the design at an early stage, this enhanced airtightness does not lead to the building requiring complex mechanical ventilation systems, as other options such as passive ventilation strategies can be implemented. We can, however, only take full advantage of this flexibility if we can depend on achieving the air leakage targets that we use in the design process. As we can see here, if we keep the air barrier internal, that means a lot of tape and mastic required to seal all the switches, sockets, pipework and other services that modern buildings require. A lot of the sealing can be done off-site, but it still takes a lot of time to do correctly and further care is required to ensure the seals are not broken or damaged during transportation and assembly. Even small punctures, broken or misaligned seals or loose tape can significantly increase the air leakage rate when tested, leading to expensive and difficult remediation measures to meet regulation requirements. This process can be speeded up somewhat by using proprietary seals and components, but this can increase costs and complicate supply chains. Using a fully adhered external air barrier removes this problem completely, ensuring that the panels arrive in position perfectly sealed and the performance and practice match the design criteria without requiring any unusual measures or specialist products during the construction process. In volumetric systems, incorporating an external air barrier is straightforward and brings several benefits over traditional mechanically fixed membranes. The membrane can be applied to the new panels in any orientation, and being self-adhered requires no mechanical fixings. This adhesion reduces the potential for membrane damage, both during the module assembly process and whilst in transit to site. The panels are then assembled and the joints taped using the same material in tape form, ensuring no adhesion issues or tape compatibility problems. Once the joints are taped, the panel assembly is resistant to air leakage, and any service installations such as wiring or pipework can be undertaken independently without risking damage to the airtight layer. These wall, roof and floor panels can then be assembled into modules, and the wrap-tight split liner tape used to complete the airtight seal between adjacent assemblies. This tape simplifies making such joints by splitting the release liner in half, allowing the two surfaces to be stuck independently, making the joint faster and more accurate. These completed modules can then be transported to site. During transportation, the self-adhered membrane ensures watertightness, protecting internal components and minimising on-site remediation work. The building can then be assembled on site and completed as normal. Many systems are accredited within BOPAS, Building Property Assurance Scheme, which offers assurance of structural integrity for modern methods of construction. To date, wrap-tight is currently included within 2 systems. The airtightness advantages of wrap-tight can also be realised in warm roof applications, such as we can see here on this local authority children's home in Hampshire. In this case, the wrap-tight membrane is used on both the timber frame walls and roof, allowing the airtight layer to remain fully continuous around the entire structure. The wrap-tight membrane is fully BBA certified for warm roof applications, making this type of construction a simple and effective route to good air barrier detailing on site, as the membrane on off-site panels can be jointed simply with wrap-tight tape. Alternatively, if the roof membrane is installed on site, it can be simply wrapped around the eaves and lapped onto the wall panels without leaving any gaps for air leakage or water ingress during construction. As well as ensuring the integrity of the air barrier is maintained, the self-adhered wrap-tight membrane brings important benefits in terms of fire resistance. Since December 2018, membranes used in external walls over 18 metres in height have required a minimum fire rating of B-S3D0. In Scotland, this is reduced to 11 metres in height. While there are some materials with A1 or A2 ratings that can be used to provide weather protection, they typically don't offer sufficient vapour permeability to ensure a healthy building envelope is maintained, by allowing construction moisture in particular to dry out. Class B membranes are far better in permeability terms and don't usually contribute enough calorific value to have a significant effect on the development of a fire. The BR 135 guidance document uses the following model to illustrate the development of a fire. A rapid fire spread occurs when initial fire develops and flashes over and is then spread to all areas simultaneously by the outer cladding layers. This then starts fires across all the areas of the building. In cases of restricted fire spread, the initial fire develops and flashes over, but it is then either contained or will ignite a single secondary fire directly adjacent. The fire will only develop further if this secondary fire also develops. This is a much slower process. Let us consider solely how the membrane in façade construction reacts to fire. If the membrane is mechanically fixed and taped, there is a potential for fire to spread on both surfaces of the material, as oxygen can feed into the fire on either side. This additional oxygen supply can also allow the fire to develop more rapidly. With a fully adhered membrane like Raptite, only the outer surface can contribute to the development of the fire, as there are no gaps between the membrane and the substrate. This inhibits the supply of oxygen to the fire and slows down the spread of fire across the membrane. So, we've looked at how the Raptite membrane reacts to fire and how it complies with the relevant technical standards. But if we want to go beyond fire resistance and introduce a degree of fire protection, then another option is to use the Fire Shield membrane. Fire Shield is a vapor-permeable membrane with a unique surface composition which actively reacts to prevent fire taking hold. Fire Shield can be used over insulation boards to provide an additional layer of fire protection to the internal structure of the building, or can be used directly onto the sheathing boards of a timber frame structure. In this comparative test conducted by the University of Edinburgh, based on the EN 13823 single burning item test, the Fire Shield on the left reacts substantially less than the other Class B fire-resisting membrane on the right. The surface of the Fire Shield acts similarly to an intumescent coating, frothing up to protect the insulation boards and structure. In this test, the unique coating protects the sheathing long enough for the external fuel source to be exhausted and for the fire to self-extinguish. The standard Class B membrane, although it shrinks away and does not contribute to the development of the fire, does nothing to protect the structure or delay the progression of the fire. Used in this way, Fire Shield can help prevent fire from outside the building, causing damage both during construction and in service. During the construction process, Fire Shield can also be used on the external cavity face to improve fire robustness of closed panel assemblies when installed over external sheathing alongside suitable non-combustible internal linings. Fire Shield is the first fire-resistant vapor-permeable membrane approved for inclusion in the Structural Timber Association tested product listing for fire robustness during construction. As part of an appropriately tested construction, Fire Shield can be used as part of a system to limit the spread of fire, which can allow for reduced spacing to adjacent properties. This must, however, be done in accordance with the Structural Timber Association's procedures and test methods. The first of our example projects is a new build apartment development where the original design called for an air leakage rate of 5 and used rigid PIR foam insulation over a concrete frame. After the tragic events of Grenfell in 2017, a priority for this project was to replace the originally specified PIR foam insulation board with the incombustible mineral fibre. This introduced a substantial shortfall in thermal performance, which the designers were not keen to offset via increased thickness. Specifying Raptite as their air barrier membrane allowed the designed air leakage to be reduced from 5 to 3, going some way to offsetting this increase in thickness. As well as the obvious reduction in building footprint from the reduced insulation thickness, there were several additional benefits. A detailed WUFI condensation risk analysis on the use of Raptite allowed the removal of the internal vapour control layer and its associated installation costs. The use of Raptite also allowed a reduction in the specification of the sheathing boards, owing to the weather tightness of the membrane externally, and reduced the requirement for EPDM membrane over the structural frame, infills and at flashings around windows. Taken together, the cost savings from these changes more than offset the increase in membrane costs from the use of Raptite, allowing the specific project goals of improved fire performance to be delivered alongside a cost saving. Our second example is a recladding project, where an existing residential high-rise with a facade of ACM panels was being refurbished and upgraded to incorporate a material with enhanced reaction to fire performance. In this project, the existing ACM panels and rigid foam insulation boards were completely removed from the facades and replaced with mineral fibre insulation and incombustible cladding panels. As part of these works, the vapour-permeable fire shield membrane was specified to provide additional protection not only from weather but also from fire spread within the cladding system. As part of a project specifically focused on reducing the combustibility of the entire facade construction, the intumescent surface of the fire shield membrane made it the obvious choice of membrane to provide temporary weather protection without compromising the overall project objectives. So whether the primary aspects of a project are airtightness, weather tightness, or fire performance, construction membranes have an important role to play in facade systems and off-site construction for both new build and refurbishment projects. Now we'll move on to the Q&A session.
Good morning, everyone. I hope everyone is keeping well and looking forward to the weekend. My name is Carol Michalak, and I am delighted you've taken the time to join us for our 9th webinar of 2021. For those of you who are regular to our webinar series, you will already know that Kira, our Managing Director, who usually holds these Q&A sessions, is now off on maternity leave. And I am absolutely delighted to let you all know that Kira and her husband are now proud parents to a beautiful boy who was born on Friday, the 7th of May. Now the real fun begins for them. We wish them all the very best, as I am sure you do too. So just to confirm our format today to anyone joining us for the first time, we aim to stay on here and answer all of your questions. So feel free to post them into the YouTube chat here, or you can send us a direct message to our Twitter page @Proctor Group, or drop us an email to webinar@proctorgroup.com. Now, if you can't stay on to the end, or if you think of something after you have left, don't worry at all. If you just get in touch with us, leave some details, we will certainly get back to you. Now, if you have registered today, and you still can register if you haven't done so already, you will get a follow-up email from us that will have a link to watch back this full webinar. There will also be details on how you can request your personalised CPD certificate. Please feel free to forward that email on to any friends or colleagues that you think might find today's content interesting. If you'd like to see any product samples or arrange a virtual meeting with one of our team, please do get in touch. Phone, fax, email, web chat, social media, carrier pigeon, we don't care. Take your pick. We're always happy to see what you're working on and want to help in any way that we can. You can, of course, also watch back any of our previous webinars, both from earlier this year and last year, and these can be accessed from either the YouTube channel here, or you can go to our website, www.proctorgroup.com, and have a look through our webinars and Learning Hub pages, where you will find lots of interesting content to watch back at your leisure. As always, we really do appreciate you taking the time out of your busy day to join us for these sessions. So if possible, I would like to ask if you could just take a few seconds when you leave us today and give us some feedback. All the feedback is read and it helps to shape content for future presentations. Leave us a comment, give us a thumbs up, and subscribe to our YouTube channel, where you will get notifications on all the future webinar content and details on other things we're involved in as well. Which brings me nicely on to our next webinar, which is now available for registration on our website. This takes place 2 weeks today, Friday 28th of May at 10 AM. Topic next time round is detailing, buildings, weather and the seasons. We will have a very special guest presentation that time round from Professor Stephen Skaisbrook, who is from Birmingham City University's School of Engineering, Computing and Built Environment. Stephen will be covering the effects of weather on building design, as well as the fundamental physics behind the weather and the seasons. Now, that is certainly sure to be a really interesting presentation. So please register now and join us back here in 2 weeks for that. Okay, so let's now move on to our Q&A session, and let me introduce you to our panel of experts. With us today, we have Mark Lambourne, who is our Business Development Manager. Good morning, Mark.
Morning, Carol. Morning, everyone.
Good morning. Next, we've got James Brackenreid-Johnston, who is our Specification Manager. Good morning, James.
Good morning, Carol. Good morning, everyone.
Good morning. And we also have the lovely Pamela Howitt, who is our Senior Technical Advisor. Good morning, Pam.
Good morning, everyone. Good to see you all.
We have some questions in already, I can see, which is absolutely fantastic. Do keep them coming in. And as always, bear with me as I am gathering them in from various different sources. So let's start with some that are coming in on the YouTube feed. I can see Caitlin Andrew has put one in quite early on, just before the presentation started. I hope the presentation covered your query there, Caitlin, but Mark, is there anything you'd like to add to Caitlin's query? She's asking about, actually, I've got too many screens open here now, actually. Let me just jump back, sorry. I'm designing a hybrid building for a project at university where it uses corten steel panels and brick in the facade. How would you design the airtightness system?
Right, okay. Well, I think the presentation covered most of that in terms of how the wrap-type membrane would be installed, fully self-adhered back to the sheathing board, and the construction as a whole, whether it's a concrete construction, for example. So the corten steel facade panels, they naturally rust over the time. So the metal sort of oxidizes and you sort of forms a patina veneer to the panels. It looks a fantastic finish to the building, and that mixed with brick would form a great look. So with regard to the panels themselves and or the brick facade, then they're typically installed on a sort of a rail system. So the membrane itself has a degree of self-sealing through the membrane itself. So it's no issue at all to fix that rail system back through the membrane back to the facade or sheathing board and or the construction. Yeah, no issues whatsoever in terms of moisture ingress, air tightness, and that type of thing. But best thing to do is just get in touch, let us look at some of the details, and then we can take it from there and advise accordingly.
Excellent, thanks, Mark. Okay, let's stick with some of the YouTube questions. James, if I could put this next one to you. Michelle Paul has asked, should the focus be on airtightness or on U value?
To coin a phrase, great question, thank you. If we take it back historically into construction methods from last century, what you're looking at is obviously the development of the industry over the decades. So obviously, initially, historically, you're looking at solid wall systems. Then we looked at cavity systems. Then you looked at partially filled cavity systems, predominantly with a rubble or hardcore. Then you looked at insulation with the development of insulations. You looked at partially fixed with mineral walls. Problem being then was that obviously it was found that mineral started to slump over the years that it was installed for. And then your rigid PURs, then your PIRs, and your phenolics were developed by the manufacturers, obviously from a thermal performance point of view. This information was obviously passed to government, which basically helped them improve the performance from a U value point of view, from a thermal performance point of view, and stipulate in building regs that, you know, these products can be manufactured, they achieve this rating, and you can achieve, obviously utilizing the Glaser method, as Kira mentioned during the presentation, you can establish what U value achieve. Obviously, as the decades have gone by, the U values have become more and more onerous, and so the thickness of insulation obviously increases. The problem that we're facing at this moment in time is a saturation point, or indeed the law of diminishing returns, where the volume of insulation that you can actually utilize is not improving the U value to the degree that you actually want. But what you're doing is obviously encroaching on your internal usable space if you've got your floor footprint already mapped out, or indeed increasing and encroaching on neighboring properties. So therefore, from a new build perspective, you're not going to be able to put as many properties as you want on there. Airtightness is something that has, for the UK especially, is something that's only recently started to be a focus. But what we're trying to do is obviously get the education out there that airtightness is important, and airtightness is something that can aid and abet with obviously that massive insulation that you're utilising within your building envelope. Taking that airtightness line to the outside of the property will improve obviously the air leakage from the property. And obviously taking in consideration the regulations which stipulate that sort of minimum of 7 on your air permeability rating with a backstop of 10. What we're hoping is obviously, well, what we know for the future is that minimum will be brought down, which obviously integrates the usage of mechanical ventilation heat recovery systems and other systems that are available in order to keep that stale air from contaminating the occupants of the property. With airtightness, it is more and more predominant at this moment in time. People are concerned in regards to being too airtight. People are regarding how do we deal with that stale air within the property. Obviously, with MVHR systems, the issue that people have with those is the fact that they are expensive. There are other systems that are out there at this moment in time that can be utilised, but depending upon the air passivity rating that you're going for, the MVHR system is pretty much the only way in order to make the MVHR system, pretty much the only way in order to make sure that your building is airtight, because it performs to its best degree below 5 cubic meters per hour per square meter. If you utilize it over that, then you're going to have a problem because it's not going to be performing properly. So if your designs are to over 5, then worst case scenario, as a standard for building regs, utilizing trickle vents, extract fans, is still viable. Continuous extract ventilation, so the low level extraction ventilation systems, but again, it's where the airtightness isn't quite what it should be in regards to the envelope of the building. You've also got positive input ventilation, which is generically where you'll have a single unit up in potentially the loft space, which pumps in fresh air into the house and relies on those cracks and gaps within the building envelope in order to expel the stale air. Passive stack ventilation is obviously something that's utilised mainly in the high-rise industry. But obviously from a low-rise perspective, if you negate the obviously negation of the chimney as well, but what this does is create a sort of chimney effect through the building, but it does rely on the wind basically to work the system as well. So from an airtightness point of view, it's something that needs to be focused on. The U value does need to be focused on, but what we're looking at now as well is utilising SAP and SBEM to show that the airtightness can actually aid and abet with the thickness of insulation. So actually you don't need as much insulation within that building if you've got that airtightness line. And obviously, as Kira mentioned, the RapTight has that airtightness line on the outside of the property. You're not solely reliant on your VCL for your airtightness line through lack of penetration, obviously from an external point of view. In regards to fixings and fittings from the external point of view, it's well worth noting that obviously any penetrations that are going through that system do need to be dealt with on site. Obviously, as designed and as built, you've got different problems from a design point of view, you've got different problems from an on-site point of view. From Mark and mine's point of view, obviously going to site constantly to sort of do compliance reports on site. The idea is that everybody knows, it's just not the chap installing, the contractor installing the RapTight that needs to know about it. People coming in doing bracketry need to know about it as well to make sure they're not damaging the product. And if they do, then it's repaired by either the RapTight installer or these contractors, these follow-on contractors are aware of what's going on. So to put it in a sentence, both are important. Both aren't being reduced by any stretch of the imagination, and indeed they are enhancing each time the regulations come out. With the decarbonisation coming forward as well, the airtightness line will be looked upon a lot more. From the development of the membranes, obviously membranes were a fit and forget system, a throwaway specification for decades. Now people are looking more and more into the functionality of the breather membranes, the functionality of the VCLs, the performances of the VCLs, whether it's fire, whether it's vapor permeability. These do need to be looked at because there are alternatives out there. There are a plethora of different products out there that don't perform how they should.
Fabulous, thank you.
Sorry.
We'll give you a little bit of a break now, James. Okay, let's move on to another one from the YouTube feed. Pam, if it's okay if I could bring this one to you. Linda Young has asked, are there any special considerations I need to make before I start installing the Wraptite?
Yeah, James has just stolen what I was going to say about great question, but it is a great question. It's one that we get asked quite a lot, but it's also an area that is often forgotten, which is, in our mind, a big mistake. So really, in terms of planning, we're advocates of planning. Think about how you're going to tackle the building. Think about how you're going to look at the different areas. Think about the programme of works. The use of Wraptite can help that and streamline it and make it more efficient. It is a little bit different to using a mechanically fastened membrane if that's what you're used to. But with a little bit of practice, you can get quite adept with it and start seeing how it works. So it's one of these things, once you get your hands on it, you're like, the options are almost endless. There are some principles to follow, which we've touched on in the past. But, it does need a bit of planning. You do need to think about the sequencing of the installation to make sure that you don't have reverse shingles. So that's where, the membrane has like a leading edge that water can track down on. You do need to look at the preparation of your substrate. It's not just going in, making sure that you've pre-cut all your bits, you've got all your corners ready, you've got your tape, your split liner, your liquid flashing ready to go. You really do need to look at your substrate first and foremost. Make sure that there's no dust or debris on your sheathing, concrete. Take off latents of concrete, any sort of mortar snots, concrete snots, ridges, rough edges, things that need filled in because it's going to create a sharp edge. Get that prepared beforehand. Any rough areas, protrusions, nails sticking out, screws sticking out, get rid of all of them because they're going to mean that you're going to have more remediation afterwards and potential points of contact. It's very similar to installing wallpaper internally. I mean, you're not going to start whacking wallpaper and paint onto a wall without prepping it first. You do need to do that with Wraptite. It's also, don't apply it to wet substrates. We know this is the UK. We know that we're going to get rain. But if you're going to work on a facade, try and protect it if it's going to be wet. Make sure that concrete, for example, which is very affected by moisture in that respect, make sure that you cover it with a tarp or something like that to allow it a chance to stay surface dry before you start bonding Wraptite to it. It's not that it has to be bone dry, because the purpose of the Wraptite will allow that moisture to dry out. But yourself, you use sellotape to wrap something, it doesn't work if it gets wet. Tape doesn't generally like water apart from some very specialist underwater ones. So, take a little bit of care, a little bit of thought, and, you should have no problems.
Perfect. Thank you, Pam. If I could just stay with you, Pam, if that's okay. There's one on YouTube from Jake Bernardini. Jake says, with a standard 140 timber frame panel, 9mm OSB external sheathing with Wraptite membrane, would you expect the internal VCL to not be required?
Okay, so the requirement or not of a vapour control area is very much dependent on the type and predominantly the placement of the insulation. So in a lot of the situations where we can look at designing out a vapour control layer, it's because the majority of the insulation is continuous external to the frame. So in a traditional timber frame, you've probably got your membrane, your stud with the insulation, and possibly a board internally. That one you have to take into account a little bit differently, because obviously you've got cold elements of the frame that could cause points. So really it's a case of the techie favourite. It depends. It depends on the construction. You know, so drop us a note with what your construction is. A lot of these ones, a lot of these sort of wall constructions, we can do a relatively easy glazier calculation, which will give us an indication as to whether it's a problem or not. And depending on the moisture loading, depending on the type of building, going on to a roofing may be applicable, but more often than not, the glazier gives us as much information as we need. But yeah, it's a good question, and it depends on placement of the insulation.
Perfect, thank you, Pam. Okay, Mark, if I could come to you now, wake you up a little bit here. Continuing with YouTube questions, we've got quite a few here, which is fantastic. Craig Thompson has asked, what third-party accreditation does Raptite hold for the offsite construction?
Well, it's BBA certified for use in wall and also modular floor cassette construction. It's also got an additional BBA for warm roof applications. It's assessed and certified by LABC and Premier Guarantee Warranty Approval. I think, as we mentioned in the webinar, it's included into BOPAS accredited systems, and it's also a certified passive house component. There's also additional certification, third-party certification with regard to reaction to fire. So in high-rise applications, perhaps, or where fire is a consideration. So, for example, schools and other public buildings. So it's got a full suite of third-party accreditation that we can refer to and forward copies of.
Perfect, thank you very much. Okay, if I can stick with you, Mark, if that's okay. Sigrid Goose has asked on YouTube, how do I fix timber battens externally without puncturing the membrane or a roofing system? Is that one you can help with?
Yeah. So, as I said earlier, the Raptite, because of the construction of the material, those 3 layers and that adhesive fully adhered back to the substrate, there's certainly a degree of self-sealing through the membrane. But as with any sort of rail system, bracket, etc., batten or whatever it may be, you're fixing that batten back through the membrane and fixing that back to the substrate as well. So you get a very good watertight seal. We've done some independent testing with CWCT, some good results there, both moisture and their tightness as well. So it doesn't really affect the membrane. There's some further detailing we can do with Raptite liquid flashing as well. And as James always says, the devil is in the detail. So, you know, do get in touch and we can look at those, anything specific, and, you know, detail that accordingly.
Perfect.
Add into that as well, you know, it's going back to that detailing aspect, is make sure that you don't have areas where you've got the risk of moisture ponding against it, you know, because that's then going to find a way in. So it's making sure that you think about how everything links together. So it's the holistic look at it again. And as Mark said, you know, liquid flashing and things like that. But, you know, it's the biggest risk as well is actually incorrect fixing. So you've put it in one place and you've made a mistake and you've moved it 2 inches to the left and you haven't gone back to treat those areas. So they're probably of more risk than the actual sort of fixings once all locked in, as Mark says.
Yeah. Fabulous. Thanks, Pam. We've got a few come in on email, and if it's okay, Pam, if I could stick with you while you're there. Rebecca Stewart has emailed in and asked, how important is detailing? So covering what you've pretty much covered there.
I think exactly. I think, you know, we keep coming up with this, and the guys, you know, raise some really great detailing questions every time they go on site for a compliance report. And it's critical. You think of it as like, if you don't do the detailing, it's like doing a jigsaw puzzle without the picture. You don't know what you're doing, and you're just trying to see whether something sticks together. We know there's always going to be something on site that crops up, and we can deal with that, but proper planning, proper detailing, and understanding buildability. So there's no point in putting something in where another element of it has to go in first. You know, it's just trying to make everything as robust and coherent as possible. And I think, you know, hang fire to the next webinar in 2 weeks, and that could be really interesting in the detailing aspect. So yeah, really important.
Yeah, definitely. Thanks, Pam. Okay. James, if I could come back to you now, if that's okay. Another email that's come in from Kenny. Oh, I don't have any further name, sorry. How does the Wrap-Tite bridge the expansion joints within the facade?
As per the sort of installation guideline that we produce, which you can download off the website, or indeed you can request a hard copy, we utilise a system with basically dependent upon the actual gap that you've got for your deflection that's been engineered into the system. You can utilise a backer rod, which obviously gets inputted prior to the Wrap-Tite installation, and then the Wrap-Tite looped over that backer rod in order to allow that movement joint between the two substrates. So where it goes onto the concrete, where the sort of sheathing board goes onto the concrete, then you've got that ability for the movement joint and the flex in the Wrap-Tite in order to make sure that the Wrap-Tite does not tear or is impeded by the movement of the property. Whether it's the loading onto the slab once constructed, or if it's allowing for settling, there isn't a problem in regards to that.
Perfect, thank you. If I could just stay with you for another one, James, an email in from Robert Granger asking, how do you deal with parapet details?
Parapet details obviously dependent upon how the parapet is constructed. So whether if you say it's a cast on site parapet, or whether it's a metal frame bolted to the slab afterwards, there's not an issue with the Wrap-Tite sailing up or sailing down, I should say, sailing down the parapet. Obviously, in conjunction, generally speaking, on a parapet detail, there'll be an EPDM of some description. So therefore, the junction between that EPDM needs to be thought about. If the Wrap-Tite is going over the capping of the parapet, the cap of the parapet, and then down the other side, obviously we need to know what roofing membrane is going to be utilised, what's the termination detail in regards to that material. Indeed, do we bond to that material? So we can carry out tests in order to, Pam, can carry out tests in order to make sure that we bond to that material, or indeed it bonds to us. But we've carried out tests with felt systems, with cold liquid applied systems, so your polymethyl methacrylates. So there's no, whichever way you're going to design it, as long as we know about it and can plan it with you, then there won't be any issues in regards to that.
Perfect, thank you so much. Pam, if I could come to you with this one, this is probably quite a good one for you being based at home here in Scotland. Callum Trahan has asked on YouTube, morning guys, morning Callum, I just wanted to make sure I picked this up correctly. In Scotland, Reflect-to-Shield cannot be installed above 11 metres.
That will be if you are doing a new build, 11 metres compliant with the fire regulations up here. So it's the same as the 18-metre rule in England. We are just a slightly lower level, as are Wales, if I remember correctly. But so I mean, we're at this moment in time, that is correct. But 11 metres is probably around about the cut-off point with timber frame anyway. So we would normally be using the Reflect-to-Shield with timber frame applications. Timber frame probably won't go beyond that just because of its limitations in height anyway. You then have to look at other things in there, and that's where other products like our Fire Shield might be more applicable anyway. So that's where we are at the moment. We are looking at, as we are with all of our membranes, constantly looking at the fire performance and sometimes trying to take them that step further in the testing scenario and the classification scenario, just to see where we can get with them, and to aid designers to give them flexibility of products. You would think that with the metallized it should be quite good, but watch this space, and hopefully we might have something at some time in the future to say that Reflect-to-Shield can be used further up. But at this moment, in new build, new designs, you are limited to below 11 metres with that in Scotland.
Perfect, thank you so much. If I could stay with you, Pam, just whilst we're discussing Fire Shield here, Mel Farage has asked on YouTube, why use Fire Shield on mineral fibre, which is non-combustible?
You can use fire shield on mineral wool. You're absolutely right. Mineral wool is non-combustible. There are obviously some grades that are more suited to being left exposed into a cavity than others. So you would use your fire shield in the situations where the mineral wool that you're using is not a cavity-based one, where it is designed to be, losing my train of thought here. So where you're not using a cavity-based one and you need to protect it, that's where fire shield would suit. Where fire shield is really good is if you've got a different substrate or something that you're looking to protect other than a sort of a cavity-based mineral wool. So again, it depends on your construction, the type of mineral wool, etc. And some people just want that added protection to stop air movement through the mineral wool as a double sort of protection with the Airtight behind it. So there's different ways to tackle it depending on your project. So if it's a specific one you want to chat through, get in touch with us and we can do that.
Definitely. Okay, let's move back to some emails we've got in here. Mark, if I could put this one to you. Stephen Crow has asked, we have historically stored our modules in the yard with the breather membrane providing temporary protection against moisture ingress. What are your recommendations for leaving membranes exposed?
Well, our range of construction membranes is typically weather resistant for up to 3 months. However, we're sort of aware that they may be exposed for longer than this, and this could be for a number of reasons. So we've actually, my colleague and I escaped out of our respective four walls earlier this week, and we went to a manufacturer, a large volumetric manufacturer, where the modules stored outside. And they could be installed outside for up to 12 months. And it can also be on high-rise residential projects where you're waiting for the brickwork contractor or for the Façade guys to catch up once the membrane's been installed. So we're aware that, whilst we generally say 3 months, that they can be left exposed for longer than that. So what we embarked on really throughout 2019, so really before all this COVID malarkey sort of happened, that's quite useful that we did it actually. We sort of looked at the factors that should really be independently assessed in terms of the importance of protecting a roof or a wall construction. And in terms of membranes, there are three main characteristics. So one would be the moisture vapor transmission rate, so the vapor permeability, water holdout, and also air tightness. So we had it tested independently quarterly throughout 2019. And what we found as the results really was that the water holdout remained W2 for a 12-month period, W1 for 6 months for roof applications. So really by specifying a more robust and I guess a self-adhered membrane, you can maintain performance and prevent the expense of stripping and replacing. So that was a situation with the guys we met earlier this week where they were putting the units outside, storing them. The membrane very, very quickly started to deteriorate through UV degradation, moisture ingress, that meant bringing the unit back in, replacing the membrane, replacing a lot of the sheathing boards, etc. as well. So it's a bit false economy trying to use a so-called cheaper membrane.
Yeah, absolutely. Mark, if I can stick this next one to you as well. Suresh Patel has asked on YouTube feed, what is the suggestion for SIP construction?
Well, for SIPs, as with a lot of the constructions, and I guess we touched upon it within the presentation as well, is that the Airtight can be bonded, really wrap the whole of the construction, so the walls and the roof, to provide that external air tightness line, simplify that design, provide sort of moisture, prevent moisture ingress, etc., etc. So yeah, suitable for a whole range of systems, including SIP. Yeah, lots of examples where it's been used on SIP construction. So again, get in touch and we can look at it in more detail.
Absolutely. Okay. Email come in from Bob Eden. If I could put this one to you, James, if that's okay.
Yeah.
Bob has asked, how does the choice of insulation material, for example, mineral fibres or foams, affect the fire performance of fire shield?
The product itself is tested as a standalone product. and also tested obviously against certain substrates. So whichever substrate you've got that you're potentially going to utilize, then obviously we can provide you with the data for those test results in order to make sure that it conforms to the regulations that you require.
Perfect, thank you so much. If I can actually, I'll just stay with you with this one, James, if that's okay.
Yeah.
Sigrid Fuss has asked another one on YouTube. Does building orientation affect a WUFI calc? If so, we have a housing development with many individual buildings. Would the calc have to be done several times, or would a site-specific calc work?
Generally speaking, what we take is obviously if the building orientation of each of the different properties is different, what we do is take the 4 walls of the property and then carry out the WUFI on the worst affected wall in regards to humidity class. And then that would obviously complement obviously the other 3 walls at the same time. But ultimately, depending on the size of the site, depending upon the proximity with each other, then yeah, ideally we'd like to carry out a WUFI on each individual one in order to ascertain the correct details and the correct results for each project.
Yeah, it depends on the building with that one as well. Sorry to butt in with that one. So we will take the site conditions, so the general weather conditions, and look at it. And as James quite rightly said, we'll take the prevailing weather and we will normally look at the worst case scenario. So that's usually a north facing wall. So as long as you know the north facing wall is working in that site, as long as those walls are the same, that's fine. It's when you start shifting the construction build up, then you would need to do the extra assessments. Depending on the wall construction, however, in a lot of cases, WUFIs aren't necessary. You know, the glazier method is still the approved method of assessment in the UK under BS 5250, and that's not going to change. So for most framed applications, etc., and masonry walls, it's only where it's coming into like solid masonry or, you know, other assessments where WUFI really comes into its own. So again, site specifics, give us a shout and we can talk through.
Perfect, thank you, Pam, for that. Mark, if I can jump back to you, if that's okay. Praveen has asked on YouTube, how does NHBC or LABC warrant Raptite, especially with removing internal VCL?
Yeah, we've had this quite recently, particularly with modular offsite. So the likes of NHBC and others, warranty providers, they're looking for worst case scenario. So with the NHBC, for example, they've got specific boundary conditions for walls, for example. So it's really through the use, as Pam said there, with the traditional glazier method is the method that they prefer. So you know, we'll look at each project on its own merit. We'll look at that through wall construction, as Pam said earlier. It depends on the type and the placement of insulation. Yeah, we'll look at each project, as I say, on its own merits, carry out that sort of hygrothermal assessment, and then take from there, really. So yeah, there are situations where, you know, in some cases you don't need a VCL, depending on the type of insulation, the placement, etc. In other cases you do, and that can be a reinforced membrane. So we manufacture those, both standard, variable, and also fire rated membranes. But in some cases it's just simply a duplex plasterboard can solve the issue. So they're looking for, I guess, a balance between moisture management and this hygrothermal assessment through the whole of that construction. So again, get in touch and we'll look at each in its own merits.
Okay. Right, James, if I can come back to you, if that's okay. Mel has asked on YouTube, is Raptite suitable for use on pitched roofs?
Yes, as per in the presentation, what you can see is obviously dependent upon the build-up of the pitched roof, so a warm roof system, then you can utilise the Raptite, but you know, every project is different. So please send us the details through, and obviously what we can do is establish the viability of utilising Raptite on that roof.
Okay, let's go back to another email that we've got. Pam, if I could bring you this one from Paulina. Paulina Myers has asked, can I really omit the VCL within the wall build-up? What about the SFS? Won't it be affected?
Yeah, so this is obviously quite a recurring theme and is something that, you know, is a bit different. In a lot of cases, the VCL has always been considered the airtightness line. So it's not just a VCL, it's an AVCL. So sometimes getting your head around taking the airtightness line and just looking at the moisture separate to that can be a little bit disorientating. So as we've said before today, it depends. It depends on the balance of the insulation, how much you've got externally compared to internally, the type of insulation, the type of building that it's going to be used. So something that's an office or a warehouse is going to have a much different moisture loading than something like a laundry or a hospital or a professional kitchen, that sort of thing. So we need to look at things like that to make sure that it's the right thing to do. You need to consider things like, the amount of penetrations that are going through the internal walls or the risk of that happening in the future. So, if you're going to have a lot of areas which are weak spots for moisture to go through, you may want a separate vapour control layer to limit that. Or look at clever ways of taking all your piping or cabling in ducts so that it doesn't impact on the wall quite so much. You also need to think about your ventilation strategy, your humidity strategy, how you're going to deal with any moisture that's generated at source, how likely that is to be maintained over the years. So something like a controlled building with a maintenance officer, that may work better long term and have less likelihood of breaking down or not working or reducing efficiency compared to somebody who's being expected to look after their own home. So it's taking the building, the services, the long-term strategy, the end user, the owners, the stakeholders, everybody into consideration. And it can be sometimes that the risks are too high to admit that. But as Mark said, a vapor check plasterboard might be all that it needs. It might not need that same level of performance as because you've got your air tightness already. It's there purely to manage the moisture rather than both. So
yeah. If I could just stick with you with this one, Pam. Philippe has sent us a message via Twitter. We've covered a bit of this. You might want to add more. How robust is Raptite on the building?
Yeah, so I think Mark touched on it brilliantly with the modular side of things, where they were wrapping their systems and having to then bring them in partway through the storage facility just to rewrap them. We've heard stories of building sites, certainly high rise, as soon as you start getting up and there's more wind and there's more pressure on it, mechanically fastened membranes are basically destroyed, they're shredded. We've had some brilliant photographs and video footage set in where you can see flags and loose bits of tape and things like that, sort of like flying out horizontally, yet there's not a movement from the Raptite. And because it's fully adhered, it means that it's not going to be influenced by these external sectors. The membrane itself is quite a robust, heavy-duty membrane, but as I touched on earlier on in one of my questions, it's only as robust as it's installed. So if you're very rough handling with it, you do have that risk of puncturing it. So it's treat it with respect, fully bond it, make sure you install it well, and it is very, very, very robust.
Okie doke. Thank you, Pam. We have got one here that's coming to us actually via LinkedIn from Mo. James, if I could put this one to you, if that's okay. Mo asks, do you need thermal brakes on the back of the hanging brackets?
Once the Raptite's installed, then from a proxy group policy, basically, we'd always stipulate that thermal brakes are utilised behind there. Not only, obviously, does it negate a larger cold bridge from the fixing itself, from the bracket itself, but ultimately fixing back to the Raptite, obviously, where the fixings go through the sheathing board. You've got, obviously, as Mark said, the self-sealability of the Raptite, partial self-sealability of the Raptite, but with that, with the torque strength that the bracket's put on with as well, what it will do is enable a seal around with that bracket to push against the Raptite to seal that from an airtightness point of view as well. Perfect.
Thank you, James. Actually, if I could just stay with you, James, Ken O'Neill has asked a question. Hi, Carol. Hi, Ken. Is interstitial condensation a concern in situations where fibre cement sheathing boards already have a factory applied moisture-resistant acrylic coating?
Again, send us the information in regards to the board itself, and through the physical components of that product and the build-up that you're producing, we'll be able to carry out an analysis on that with that in the build-up, and therefore stipulate with the build-up where it is, what the orientation of the property is, whether there's going to be an interstitial condensation risk within that property.
Excellent. Okay, let's move on. We've got some more emails in here. Mark, if I could give you this one. Gail Spinks has emailed asking, do you have a Class A or Class A2 breather membrane for buildings above 18 metres?
Well, at the moment, there is no requirement for membranes to be Class A or A2. We are certainly seeing the introduction of these, but actually under the amendment to approved document B for November 2018, it limits the use of membranes to a minimum rating of Class B S3D0. So it really recognises that membranes not only have to react appropriately in the event of fire, but just importantly, and something that may be overlooked, as we said earlier, take this holistic approach, is actually this product's ability to breathe. So that is just as important. So there's no point putting a membrane on that ticks a box in terms of fire if it doesn't actually breathe and suitable for the UK climate. So what I would suggest is that certainly Class B membranes offer a higher vapor permeability. Wrap-Tight is Class B S1D0. But if you want to specify a Class A or A2 membrane, then I really recommend suggest that you look and request for a copy of the third-party accreditation, really to confirm whether the reaction to fire is as it suggests, how it works as part of the system, and actually whether it conforms to BS 5250 in terms of vapor resistance. But I guess also look at, as we spoke earlier, about what happens with regard to UV degradation as well. So and water holdout. So lots of things to think about. Take this holistic approach to these things, and don't just rely on perhaps the marketing claims, etc. You need to actually look in great detail when you're specifying these type of membranes.
Definitely. Okay, another question that's come in here on email. James, if I could give you this one. Frank Atherton has asked, how does Wrap-Tight work at junctions with fire barriers within a cavity?
Okay. With the Wrap-Tight, obviously what we push is obviously the holistic view, so it's a full envelope wrap. So with the Wrap-Tight and fire barriers, there's no need to terminate and restart the Wrap-Tight on the other side before and after the fire barrier. Install the Wrap-Tight, then utilize obviously the fixings for the fire barrier, if there are fixings, through the Wrap-Tight. What I will say again is obviously where you've got these contractors coming in, predominantly it's not going to be the Wrap-Tight installers that are installing these fixings for the fire barriers. So what I'd say is obviously make sure that they're aware of the performance of the Wrap-Tight, why it's there, and if there's a sort of a snagging that needs to be done once these brackets are installed for the fire barriers, just in case they put a bracket in, realize they put it in the wrong place, unscrewed it, put it back into another place, then the Wrap-Tight can be repaired. Those punctures in the airtight membrane can be repaired in order to make sure that airtightness line is maintained.
Yeah. There's another one here that's come in on email, James, that you can probably just cover quickly. Ian Routh has asked, can Wrap-Tight replace the need for EPDM on window apertures and other penetrations?
As with the VCL integration, whether it's required or not, what I'd stipulate is speak to the warranty provider for the build, speak to the client, see what their view is upon the system. If it's a fact that we can have a conversation with them, we can explain how the product works, we can explain the performance of the product, then what we can do is obviously, hopefully, depending upon the tolerances as well, because obviously from an on-site construction point of view, what we find is that the tolerance around the windows and doors is a lot larger than what you get from an off-site construction point of view. So therefore, there is still a place for EPDM or another alternative that manufacturers are developing at this moment in time. But utilising the Wrap-Tight does turn into the reveals of windows, of doors, in order to maintain that airtightness line. The junction between the EPDM, whether we're underneath the EPDM, whether we're over the top of the EPDM, it's not really a problem. But from our point of view, obviously, depending upon what EPDM is being utilised, sometimes it can have a finish like the surface of the moon. Sometimes it can be fairly flush. So what we'd like to see is on the flush side of things, there is no issue with the Wrap-Tite bonding to it. But if you've got a very undulating surface, to get a decent bond with the Wrap-Tite is fairly problematic. So in that case, where it's undulating, we go underneath. If it's a nice smooth product, then we should not have any issue bonding to the product itself. But again, speak to us first. We'll detail it with you. We'll make sure we bond to it, or indeed it bonds to us.
Fabulous. Some really great questions coming in today. Thank you, everyone. I can see on the chat there's a few people that are having to leave already. Don't worry if you think about anything afterwards, just get in touch with us and we'll come back to you. Or if you do need to leave your questions not being covered, just watch it back. As we always say quite a lot of the time, a lot does depend on your individual application. So if there is something in particular that you are working on, we can help with, please do pick up the phone or drop us an email with some drawings and we can certainly look over that for you. Okay, and now I've actually only got a handful of questions left. So if you still have something you'd like to ask and you can hang on with us, please drop it into the chat now and we will get that covered. Okay, Pam, if I could put this one to you, another email that's come in from Spencer Fox. He has asked, fire shields, how does it perform on a timber substrate? Does it need to be an FROSB?
Yeah, so this is a great question. I mean, obviously we covered it in the webinar. We've touched on it a couple of times. Fire shield is quite a unique type of product in that it is a breather membrane, but it's got this intumescent coating that reacts to fire and helps to starve oxygen off it and stops the spread of it because of that, etc. Now, one of the real key benefits about it is that we have gone down the route of ensuring that we test on applicable substrates. So we have that independent UCAS accreditation to show the performance of Class B remains Class B, even on a standard particle board, OSB or plywood board. Some other membranes can claim that they have a Class B, but that might just be on an A1 or A2 system. When you start looking at the nitty-gritty of it, it may be that it's only a Class B, and that's because those membranes kind of flash off and disappear quite quickly. Yes, they don't contribute to the fire by, causing pools and burning droplets and things like that, or adding energy load to the fire. But what it does do is it does mean that then that backing is exposed, so that substrate is exposed, and that can then influence the fire test. That doesn't mean to say, so that's where sometimes they have a free hanging result, but obviously that's the free hanging test shows how that particular product works. Again, what is always good is to look at it, not just that, but, together as a system. So there's a lot more going on with this at the moment. So the STA, for example, the testing that we did, that we showed in the video of the corner cribs, that was submitted to the STA, means that it can be used in closed panel situations. It's in their covered and approved products. And, as a result, we know that that's a very robust product on timber frame, and, that's exciting a lot of people. So that's protecting it during construction and can mean that you can build closer to a boundary depending on the building orientation, etc. So that allows the designer of these STA separating distances to potentially add extra to the building, not worry about transfer to other buildings on site, etc. So it's quite an important move forward. So it doesn't have to be an FROSB. It can just be a standard OSB, but another system might be that has to be, like another membrane might be that you have to use an FROSB or an A1 board or something like that with it. So it's, again, touching on the points that Mark and James have already said, look for that third-party assessment, drill down as to what the parameters are, what is acceptable and what isn't acceptable. And hopefully, with that, we can drive the fire safety forward.
Perfect. There's one that's come in from, a supplementary question coming from Callum Chahan. He's asking, as for retrofitting, how does that work? Now, I'm not sure if that's in relation to a previous question that's been asked, So if
yeah, I was
anybody,
going to say, if I say that, because obviously I mentioned on Callum's thing, and I'm pretty sure that I know where Callum's coming from, because he uses our membrane, if I'm right in my people, but he uses our membrane in an internal retrofit system. So it's a slightly different situation where that's a retrofit an existing solid wall building rather than external cladding. So they are slightly different applications. So in his particular one, it's not a problem. In other ones where maybe it's a reclad, it might be a little bit of a different consideration, and especially with that, if that's going through like a building control approval.
perfect. Okay, Mark, if I could come back to you with this one. Harrison Oakley has emailed in and asked, an external self-adhered membrane would provide a simplified airtightness line to our light gauge steel frame wall, floor and roof panelised system. How do we maintain the airtightness line when joining the panels together?
Okay, well, in the webinar, I think you saw that the panels were being sealed with our split liner tape, so the Wrap-Tight split liner. So this is a tape, when you pull the tape off the roll, the release liner on the back is sort of split centrally down the middle. And actually we can manufacture or produce that split liner with that line offset if necessary, or even with perhaps two cuts in it, as it were. So what this allows you to do is install the tape in two parts. So you install it in the factory. So you remove one half of the release liner, apply that to the panel. So it allows half of it to be installed in the factory, and then it leaves the other exposed edge either to be installed later on within the factory process or actually on site. The other way of doing it, as we saw actually yesterday on a site using a panelized system, you bring the panels into place, you abut those, and then you just use our standard Wrap-Tight tape to seal that join there. So that will prevent moisture ingress and obviously provide and seal that air tightness line. We've also got, in the case of the tapes, wherever you're installing those tapes, so vertically, for example, on the top leading edge, we'll just apply a bead of the liquid flashing, get a spatula and smooth that out, and that prevents any moisture ingress behind the back of the membrane. But really, as we've said throughout, any specific detailing, just getting in contact and ask for any further support and advice.
Okay. Mark, while I've got you, this is one perhaps you can make a bit of a comment on. Brian Murphy has said, difficult question and answer. As we know, Grenfell inquiry has shown reputable companies have hidden facts from test houses, and test houses have been lax in calibration and inspection of rigs. Are certificates reliable? Reliable?
Well, I think because of the obviously the Grenfell inquiry, all eyes are on not only manufacturers but also the test housing themselves. So I think that certainly whatever has gone on previously, I think will be looked at certainly differently. We think it's important that we are totally honest and transparent with regard to what we do in terms of both testing, but also declaring the results. That can at times mean we've got difficult situations to deal with where it's probably not the answer that the contractor's looking for. But it's better, I think, to be honest up front and through obviously innovation, etc., products will improve. So I think, yes, in the past there has been lots of use of smoke and mirrors and that type of thing, for want of a better phrase. But actually, you know, as an industry, we need to improve. And as every politician will say up and down the land, you know, the lessons will be learnt. And I think those lessons have been learned. So it'll be interesting to see how the industry sort of you know, reacts to that moving forward.
I think that's a really good point, that, you know, lessons have been learned. It was a tragic lesson that we had to learn. But I think in Grenfell, there was a lot of faults on a lot of sides, and it just all unfortunately came together in such a horrific incident. It wasn't just certification bodies, there was a lot, and there still is more coming out, and I think it'll be years before we get the sort of full understanding. But I think one of the positives that we have to take out of it is that it is now being looked at it is now being tightened up. Regulations are being made to be less ambiguous. You know, they're sort of improving things, and rather than the bare minimum, and this is what we're seeing, people don't want to just do the bare minimum now. There's much more focus on going above and beyond. And I think we've been guilty in the construction industry to always value engineer and go for the cheapest and easiest option. And sometimes that's not the right way to do. And that's where it's really important to engage and set your specification and be adamant about not changing it. But there's a lot of good documents coming out. You know, there's like a refurbishment, the approved document B was amended. There's a new PAS 9980, which is looking at sort of fire and cladding situations. It's out for discussion and approval at the moment. So that's got some quite interesting context about certification. So it's an exciting time to be involved. It's a huge learning curve for us all. But I think actually the building industry is going to come out better for it at the end. But it's a complete webinar in itself.
Okay, I think this might be the last question that I have come in here. Pam, actually, if I could just keep this one with you. Scott Visit has asked, what does the deconstruction process of Wrap-Tite look like at the end of the building life? Is the product reusable and or recyclable?
Great question. Difficult one to answer. Simply because at this moment in time, you know, we're using Wrap-Tite in the plan that it's going to be there on a building for in excess of 40, 50, 60 years. Our biggest constraint to recycling and reuse at this moment in time is having the infrastructure in place to be able to do that. So far, you know, a lot of stuff, there's just not the ability to take it. Now, in theory, yes, Wrap-Tite is recyclable at the end of the building's life. It's polypropylene, you know, so even our manufacturers, when they're making that non-woven, trimmings, etc., are taken off, melted down and reused in other fibre and filament processes within their factory. You know, these pellets can go in and be sent off for other things. So there is the potential that it can be reused or certainly recycled and put back into, so it's not a single use, I mean, it's not a single use plastic anyway, because it's designed to last the lifetime of the building. But there is the potential that down the line, as recycling and reusing ability improves, that, you know, I can see buildings being taken down almost like they were going up, and the different elements taken away for reuse and recycle. So at the moment it could be difficult because we don't have that in place, but I think that's going to improve as time goes on, and we have to use resources again.
Okay, well, I pretty much think that's us for today. I hope I haven't missed anyone's questions. If you do think of something that hasn't been covered, or if you would benefit from a one-to-one with us directly, please do get back in touch with us. One of the team will certainly get back to you straight away. Thank you once again to our fantastic panel, although I will say I am deeply disappointed we had no props today. Oh. Let me down, guys. You've let me down.
With a split liner, because I know I've got one somewhere, but...
So please register for our next webinar, which is covering detailing building weathers and the seasons, taking place 2 weeks' time. Don't forget to subscribe to future content and leave us some feedback. That's it from me today. Thank you once more for joining us. Do look after everyone. Enjoy the weekend. Keep safe. And I hope you all start to enjoy your hugging again come Monday. Have a great weekend, everyone. Goodbye.
Thank you.